Tonight we're going to be learning about our double replacement reactions and how to use a solubility chart in order to determine if a double replacement reaction actually occurred. A double replacement, in order for it to occur, has to produce at least one gas, liquid, or solid. The liquid in this class will be water. Gases we typically won't deal with, though it does occur. And the solids that we produce will be when we combine two liquids and we make something that is insoluble. Okay, if we look at this image down below, these are two aqueous solutions, meaning I had two things that were dissolved in water, okay, and that's why you don't really see anything in it. And when they combine, what they do is they actually form this foggy substance, and this foggy substance right there that you can see, it makes it cloudy, that is a solid. And that solid is known as a precipitate. And if I had a really nice funnel and filtration system, I would be able to filter, I would be able to get all of these little solid particles out and all the liquid would be able to go through. Okay, the reason why you need to produce one of these is that the substance needs to somehow change what it's made out of in order for a chemical reaction to occur. And for double replacements, that how you can determine is if they form a gas, a liquid, or a solid. So the ones, once again, we'll be primarily focusing on are those solids which are insoluble and they look like this cloudy substance. So what is the solubility chart? A solubility chart is just a chart that is used to identify whether something would be a solid or aqueous when dissolved in water. Okay, and we're going to look at one solubility chart, and you will not have to have it memorized for this class. If you have something that says solid or solid, that means it is insoluble. Aqueous means soluble. So these two terms are synonymous with one another. So if I say solid, I mean insoluble. If I say aqueous, I mean soluble. Soluble means that it's dissolved. Insoluble means that it's not dissolved. So a solid is not dissolved in water, whereas an aqueous solution, it is dissolved in water. All right, so looking at this solubility chart, this is the one that you should become very comfortable with. All of these compounds are soluble, meaning aqueous. Okay, so any of these anions are going to be primarily aqueous, okay, when they are combined with a certain cation. For like nitrates, there are no exceptions. So a nitrate will 100% of the time always be an aqueous solution, okay, or soluble. When we are looking at, let's say, chloride, though, chlorides tend to be dissolvable in water, but unless they are hooked up with silver, mercury, or lead. If they are hooked up with any of those, then instead of following the normal rule, which would be that they are aqueous, they would be the opposite, which means that they would be a solid or insoluble, meaning you couldn't dissolve them. The exact same thing goes for the insoluble substances on the bottom. All of these anions are always insoluble, or they do not dissolve in water, except when they are paired up with these guys on the right hand side. And if they are paired up with any of those guys on the right hand side, then they are the opposite of insoluble, which means soluble or aqueous. So when we look at this, I'm asking you for calcium carbonate. Is it soluble or insoluble? So you're going to find carbonate, which is right down here. It is typically insoluble, except when it's paired up with ammonium or an alkali metal cation. Is calcium an alkali metal cation? No, it's an alkaline earth metal, so therefore it is not an alkali metal cation, so it is not an exception, so therefore it's going to follow the rule, which means it is insoluble. By definition, if it is insoluble, I am saying that it is a solid. Okay, sodium nitrate, or NaNO3. So what we need to do is look for nitrate, NO3, and it is always soluble, except, and there are no exceptions. So no matter what, if I have nitrate, it is always going to be soluble, which by definition means that it is aqueous. Okay, and now let's try the FeS. So FeS, I'm going to look for S. It is typically going to be insoluble, except if it is partnered up with ammonium, an alkali metal, calcium, strontium, or barium. Is iron any of those? Well, it is not, so therefore it is going to follow the traditional rule of being insoluble, which means that it is going to be a solid. So that means iron sulfide or iron 2 sulfide is not able to dissolve in water. Okay, but this is nice and This is all great that you can identify whether it's going to be a solid or not, but you need to be able to identify whether a double replacement reaction occurs or not. So for these reactions, what you want to do is do your little wife swap thing. So where you switch those cations. So I'm going to hook up Ca with NO3, and then I'm going to move Ag where Ca was, so it's AgC2H3O2. All right, now I'm going to worry about charges. Calcium has a +2, nitrate is a -2, so you crisscross and you get a 2 there. Silver has a +1, acetate is a -1, so I'm going to cancel by a 1, 1. Now, in order for a double replacement reaction to occur, one of these two have to be a solid. Okay, as long as you've got one being a solid, then you're good to go and the reaction will occur. But if both of them are considered aqueous or soluble, then no reaction occurs. And we'll go into the reasons why in a little bit. All right, like in another video. So we've got nitrate. So nitrates are always soluble, which means aqueous. And there are no exceptions. So I know that this needs to be labeled as aqueous. Now I'm going to look for my acetate. Acetates are always aqueous, and there also are no exceptions. So I know that I would put aqueous. So I look at my products. Did I produce at least one solid, liquid, or gas? Produce something that's aqueous and another thing that's aqueous. So no, I did not produce a solid, liquid, or gas. So therefore, this reaction would not occur, and all I would have needed to write in the end was NR. When I am grading your test, this is the only thing I am looking for when you have to be checking the solubility chart. All right, hopefully you have a basic understanding of how to check your solubility chart to identify whether something is insoluble, meaning solid, or aqueous, meaning soluble or dissolvable in water. And once again, in order for a double replacement reaction to occur, you need to produce at least one solid, liquid, or gas. They both cannot be aqueous solutions. Have a great evening.